Project 1.4, the 2-bit adder. This project consists of 3 circuits: the half adder, the full adder, and the 2-bit adder. The first and most important step in building a 2-bit adder is understanding how binary code works. As you can see from this sheet, the number furthest to the right is worth 1, and every number on the left is worth double its previous number. Using this, you can make any number using only ones and zeros. The other important component to keep in mind when building the 2-bit adder are logic gates. Each logic gate has a truth table, like this one for the AND gate, which will show its output given different inputs. As shown by its truth table, an AND gate will only output current when both its first input and its second input current. XOR, on the other hand, means exclusive to OR, so only turn on if one of its inputs have current. Finally, the last logic gate used in the 2-bit adder is the OR gate, which will turn on if either one of its inputs input current. First off, the half adder consists of all the parts listed on the table. When you have 0, 0, there's no current anywhere, so you get 0 on the carry and 0 on the sum. But when you put 1 on, that only gives you 1 on the AND, so not enough, giving you 0 on the carry, but 1 on the XOR, giving you 1 on the sum. When you turn both on, the XOR turns off because it's exclusive to OR, giving you 0 on the sum. But since you have 2 inputs going into the AND, it gives you 1 on the carry. So as you can see, you get 2 on the carry and 2 on the A and B. The next circuit is the full adder. The full adder consists of all the parts on this table. So a full adder is basically just a half adder with an extra SYN input. If you put 1, you still get 1 with the XOR here. If you put 2, you still get 2 with the OR gate here. But if you add the SYN input, puts an extra current onto the XOR, giving you another 1. And now if you take out the B, that's still 1 and 1, giving you 2 here, since both currents end up going to the AND gate and then to the OR gate. As you can see, this is just a slightly more complicated version of the half adder, and eventually this will turn into the 2-bit adder when you turn the SYN input into another half adder. Finally, for the 2-bit adder, all the parts on this table will be used. This is the 2-bit adder. It's essentially just a half adder here along with the full adder here. These two outputs are the outputs of the full adder. These two are both worth 2 each, and these two are worth 1 each. The only difference is that these are delayed. So this here, S0, is worth 1. Here, sum 1, S1 is worth 2, and the carry is worth 4, as said by binary code. Finally, the 2-bit adder breadboard prototype can be put onto a PCB, screwed onto a case with power jack, giving you a final complete 2-bit adder. Thank you for watching. Have a good day.